Before I start, right, since we have lost a bit of time, is there a way can I summarize what I'm going to talk today, right? Make it into a meaningful bite or a meaningful knowledge for you, right? Uh, I can give you a small anecdote for it, right? I see the audience, there are people from all the spectrum. I see the college students, I see some veterans, I see all the people in between. So, like, a little difficult for me to give a, I would say, a exact analogy which might fit all of you, but still, let's give it a try, right? So, what is this buzzword hybrid reasoning? So, just imagine this, right? You're working for a company and your manager comes to you. A normal working day, you're probably sitting at your desk, maybe watching some reels, and your manager comes and say, you know what, Lakshmi, there is this urgent issue that we have. Can you fix it? And you are like, sure, boss, why not? And you start coding or like whatever you want to do, and you fix it. What did happen over here? What was your response all about? Right? If you really think about it, it was more intuitive, right? Why? Because it was based on a set of rules and I would say intuitive rules in your mind. You were free, you are paid to do your job, your boss gave you a job, a work to do, right? So these kind of activities where we have kind of a pre-built rule or a pre-built workflow or a pre-built, I would say, like, algorithm kind of things where we know if this, else this, blah, blah, blah. Those kind of things are known as symbolic or rule-based AI systems, right? Let's take another scenario. So you're already working on a very high critical, high priority task. Your boss knows it. And still, on the evening of the Friday, he comes to you. He asks you, hey, Lakshmi, you know what? We have this another task which is also a priority, and this is coming from our CEO. Can you please fix it by end of the evening? What would your answer be? Will it be an intuitive yes? Will it be an intuitive no? Or will you take a pause to think? I want you to think about it. I think most of us will agree that we won't immediately answer it, right? We will take a pause. We will go through all that scenarios. Arey yaar, it's already Friday evening. Why he wants to make my life hell? One part of thinking. Another part of thinking, can't he see that I'm already held up with this current priority work? Does he not have heart to even give me the new task? Another part of it. The third part, the logical part, which mostly helps us, right? That part thinks in a logical way. Okay, if I say yes, then I get messed up. If I say no, he gets pissed off. What can I do? So that guy or that mind of us kinds of tries to find a middle path, right? It statistically correlates. It will say, you know what, boss? I do agree that this is a high priority, but can you please help me find out how can I, what is the best way we can take it forward? Should I hold this current task for the moment? Should I pull in some other persons to help me or out on this? Or what is the way that you look forward? So that's kind of the dialogue you built, right? So this also diffuses the situation. This is just one of the example, but I could go on and on. For married guys, the best one I can think of is when your wife asks, how do I look today? Right? There's not a straight yes or a no to it. You have to think. So you have to find that middle path. So that I would say is the summary of what is hybrid reasoning all about. If you understood this, I'm sure you will just go over the rest of this talk easily. Thank you. And before I proceed, let me also just debunk one of the myth. I'm not an AI developer. I'm not a data scientist. I'm just also one of an engineer, just like all of you. It just happens that I use or I like to use ML and AI mostly. So I'm over here sharing a few of the thoughts that I have on the subject. So even we get into about what is hybrid reasoning and LLMs, let's try to understand where did the AI evolve from, right? Because that also gives us the history of how it came all the way. So when AI, ML as a discipline started, and this started way back in 1950s, right? I'm sure for some of you it might be a shock, but AI and ML is not something which just started 5-10 years back. It has been around since 1950s in different forms, right? So the first thing that came in the ML was this rule-based LLM. So what was rule-based? As I said, a very predefined set of rules A basic example would be something like your credit card fraud detector, right? A very simple rule-based LLM or a AI system. So it says if some conditions are met, then tag it as fraud. Spam detectors, right? If it comes from a particular domain, mark it as spam. So these are called as the rule-based systems. The second is the era when all the revolution started, which is the machine learning era. So what happened in machine learning era is we started to take off the rules. We said, you know what, I'll give you the data, you try to inference what is the relation between the data, right? So this is the era where all this regression, statistics, probability, and all these things came into picture. This was the era where we also started to work with a bit of unstructured data. We started to find out the patterns in the data. And this is how the machine learning era was kind of shaped up. And I would say in the last 10, 15 years, the current trend that we are in is also called as a deep learning era. So what happened is scientists started to think, you know what, how we have to make system which thinks like a human, right? So let's make a system that's also mimicking the human biology. So that's how they came up with this concept of artificial neural networks. So just like how our brains have lakhs and thousands of neural connections, they try to build those kind of neural connections as well. So that is called as deep learning. And just a jargon buster, why it is deep learning? Not because it is deep, because we have multiple layers of thinking that happens. That's why it's called as deep learning. And I'm not going through it, but just if you're interested, maybe you can take a snap of it. This is how the AI has kind of evolved in these many years. I found in the net it's not really very structured, so I just thought I will put up a quick table which kind of explains to you what we have discussed so far. Okay, so where does hybrid reasoning now fit into all of this? So how many of you know what is a LLM, use LLM? Can you raise your hand? Okay, I see not many. Okay, let me just quickly then recap how any LLM works. LLM, right? Large language model. What is it? So if I really, and by the way, I'm just deviating a bit from my topic because I feel it's more important for you to understand rather than just me blabbering some jargons and going off, right? So what is a LLM if you think about it? LLM, large language model. So it's nothing but it's a model which is derived out of all the language vocabularies that has been written in the internet for the last whatever years, right? So if you take ChatGPT, you take Llama, you take Claude, you take Grok, any of those popular LLMs out there, right? So what those scientists have actually done, they have gathered all the data from the internet. Could be GitHub, could be Wikipedia, all those sources that are freely available. And they tried to come up with a model, with a database, with an intelligence, which kind of finds what is the interaction between each of those words, right? In the LLM world, we also call it as token. So what is a token? Token is nothing but the smallest form of word or the letter which is fed to a machine, right? Fed to the LLM. So, for example, right, Bangalore is a dash, right? When I ask LLM, Bengaluru is a dash. So how does it know that what to predict? Whether I should say city, whether I should say it's a traffic mess, whether I should say it's the capital of Karnataka, whether I should say it's the South Silicon Valley of India, right? You can just go on and on. Or if you are poetic, you can say Bangalore is romantic, whatever, right? So how does my LLM know? Like when you ask ChatGPT or any of those LLM, how does it predict or tell you that Bangalore is a city most of the time, right? So what happens behind the scene is the LLM, when it crunches all the data from the internet, when it is being trained, it will see, okay, whenever this word Bengaluru comes and comes, what is the next most probable word that comes in? Most of the time you will see it is the city which is there in the internet, right? So that's why you see it's a city. But not just that, every time you ask it, it will give you city. There are chances where it will give you is a city in India, is a state of is capital of state of Karnataka, blah blah blah, right? So that is where this randomness comes in. That is where a bit of mathematical things also comes into the play. I'm not getting into the mathematical jargons just to keep it little light, but I hope you get the point, right? How the LLM is fetching you the answer. It makes all these connections. It finds out for each of this token what is the next probable token that is possible, and based on that, it gives you the output. So what, if you actually think about it, what the LLM does behind the scene is nothing but it does is statistical measures, right? It basically tries to statistically derive what is the relation between all of these different words. And mind you, not even the inventors of the LLM know how it does it. Because if you actually go and read about it, people say LLM is a black box. Nobody really knows how it gives you the answer, how it derives the answer, how it stores the answer. Even the scientists who have discovered it or written it, right? Okay. So where does this now hybrid reasoning come into picture? So till now we have understood any LLM gives you the output based on the statistical measures. And we have also talked, there's another stream of ML which is called as symbolic ML, right? Or the rule-based system. What if we combine both of these world and bring the answer to make it more intuitive? That is where this concept of hybrid reasoning came into picture. And hybrid reasoning is relatively a new topic, a new focus area, I would say. Probably I would say Claude. Claude is how many of you know Claude, by the way? Okay, good. A lot of you. So there is this company called Anthropic, which is a competitor of OpenAI, which creates ChatGPT. So Claude recently, a month back, released this concept of hybrid reasoning in their latest model called as Claude Sonnet 3.7. So that's where the trend started to pick up. Okay, what is hybrid reasoning and why do we need to use it? So hybrid reasoning, as I told in my previous example, it's nothing but a model or a method where you combine the good words of symbolic AI, you combine the statistical measures, and you try to give the output. So what is the benefit of it? One thing for sure, you get more factually correct answers. Your hallucination in the system comes down. So that is one of the benefit that you get when you combine hybrid reasoning, right? One example could be, how many of you here use LLM for coding? Okay. How many of you use it for something like front end, Angular, React, any of those kind of things? Okay. In the initial days of LLMs, I'm not sure how many of you know it, but the GitHub Copilot used to hallucinate a lot. It used to give us code and solutions which were not even there, right? Even Microsoft would be thinking like, when did I ever invent this, right? So that is what is called as hallucination. Because your LLM has seen so much data and has created so much connections, it tries to bring up some random probabilities for the query that you ask. So it is in this kind of situation where symbolic AI also kind of helps us, because when we set some ground rules in the application, when we say that hey, you know what, when something is queried about this, it should be this. When something is queried about this, please check for these patterns. So it makes your answer a little more factually correct, and also it reduces the hallucination of it, right? So that is what the world of hybrid reasoning all about. Next slide. Okay. So how does my hybrid reasoning works behind the scene, right? And mind you, most of the LLMs, at least which are proprietary, their inner workings are not really shared. DeepSeek is I would say, uh, an outlier here because it's an open source LLM. But otherwise, most of the proprietary LLMs, they don't really share how it works behind the scene, right? So what I've tried to do is I scanned through a few of the papers, research articles on archive, and I saw this nice diagram which I thought will be easy for me to explain how this hybrid thinking works. So what happens, right? So let's assume that I have this task, right? Task is nothing but a user asking, what is life? Assume that is my query to the LLM. What is life? Simple as that. So what happens is, when my query comes to my system, there are two parts to it. One is the fast thinking. Fast thinking is nothing but the rule-based or the symbolic AI part. The slow thinking is nothing but the statistical measure part of it. Why it is called fast thinking? Because as I said, it is all rules, right? You break a rule, you go to the else part. You satisfy a rule, you execute that part. So that's why this is called as fast thinker, right? So what happens? I ask a question, what is life? First it comes to my chain of, COT is nothing but chain of thought. Okay. What is chain of thought? People who are not geeky, doesn't matter. I hope nowadays you would have noticed that whenever you query ChatGPT or any of these LLMs, it first does a bit of thinking, right? Okay, the user is asking me about life. Life is so profound. There are so many answers of life. We can start all the way from philosophy to spirituality to science to maths to blah, 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 right? All those are nothing but the output of this COT. Okay. So what is COT basically is we are forcing the LLM to break down its thinking, or I would say break down its relation that is trying to build. When I say what is life, instead of directly giving an answer, okay, based on the probability, life is hell, for example. I want the LLM to tell me, okay, what does it think are the relations it has built around the life? So that's why you see all those statements coming in. Life is has a lot of dimensions. It has religious meaning. It has spiritual meaning. Blah blah blah. Right. So this is what the COT is all about. It first goes to the COT. There, from the rule, it will try to see is any of the rule matching. Right. Where I can say that if this is the query or this is the token I have, this is what has to be done. If that is the case, then it goes for the verifying part of it. Verifying is nothing but I'm just enforcing that all my rules which I have set for that particular task is being met or not. Once this is done, I have the other part of my workflow, which is the slow thinker, which is nothing but the statistical measure. Statistical measure, as I said, it tries to find the reasoning around all the tokens and all the input which I have given to my LLM, right? So here what it does, here the dynamic problem workflow solver, it basically tries to break down my entire workflow. So what I mean to say is, when I ask it what is life, it directly doesn't go and say, okay, life is XYZ. It first breaks down what is life. So life, let's break it into sub problems. What is life? How can I define life? What are the aspects of life? How is life viewed by different philosophies? How is life seen from different angles, right? So these are the various sub problems which I have to solve in order to get the answer for what is life. So that is what my slow thinker does, or my statistical measure does. It breaks it into sub problems, finds answer for all the problems, combines all the answers, and finally I get my answer. So what is hybrid actually doing here is, it first validates whether I need both my fast thinker and my slow thinker. Classic example, as I said, when your boss gives you an extra work when you already have work, right? Those are the kind of situations where both of these things are required. So my LLM basically determines whether for a given task, do I need to use both my fast thinker and my slow thinker? If yes, this is the kind of the high level workflow, and finally I get the consolidated answer for it. So this is what hybrid reasoning is all about behind the scenes. Next. Okay. So enough of this bhashan, right? Enough of this lecture. So one of you may ask me, Lakshmi, what do I do end of this? I go home, I go to my company. What do I do with this knowledge, right? So one thing, I'll also show you a demo, but I would say these are the integration strategies which you can use. And mind you, you don't have to really use Claude for this. I'll also show you how I did it using DeepSeek itself. It's more about using RAG and prompt engineering by which you can still achieve this all by yourself using an existing LLM. So the first step in this integration strategy is you identify, right? So when I say identify, I am a developer like you, as I said. I identify in my project where are the areas where I think this kind of approach helps me, right? So one classic example is I have a large legacy code base. Everything breaks here and there, right? I change a small if condition and the entire application comes crashing down on a Friday evening, right? That is a classic case where my usual good GitHub Copilot will struggle to help me out because it does not have the context. It does not know why the previous developer coded a few statements the way it was, whether it was like, the compulsion of time, compulsion of infrastructure, whatever it is, right? So I don't have that, the current LLMs don't have the technical know-how of it, right? So next, what I do? Next, I then choose what are the hybrid reasoning components I require. So as I said, there are two parts to it, right? One, you have the rule-based system, one you have the statistical system. For the rule-based system, you can define something like the rule engine. So, right, what is a rule engine? People who are working in enterprise, you already know it, right? You define certain rules. Spam is an example, right? If an email comes from this domain, block it. If an email comes more than X number of times from a user ID, block it. Those kind of things. So that is called as a rule engine. What is knowledge graph? Knowledge graph, I would say, is more like a structure or a tree where you hierarchically try to plot what are the relations between different knowledge or different terms. So you then choose these kind of components that is required for your hybrid reasoning component. The third, now you bring all of this together. How do you bring all of this together? As I said, you start with your base LLM. You could be using ChatGPT, you could be using DeepSeek, your own model, whatever it is, right? On top of it, you will build this hybrid component layer, hybrid reasoning layer, I would say, which kind of does all this processing for you and then feeds it to your LLM. Remember, your LLM has no state, right? It cannot maintain state. Even in ChatGPT, when you see that the ChatGPT remembers what you have asked, it's not because it has memory. There's an application layer sitting on top of that LLM, which is doing all that work for you. On its own, the LLM is very stoic, right? You ask it something, it will give you an answer, and that's it. At that moment, it forgets. It never remembers anything out of that conversation. So the third thing, as I said, you take your LLM, build your hybrid reasoning workflow on top of it, and you're done. And the fourth part, this is the main part where all of us struggle. You fine tune it, right? So I give it my code base. I let the LLM do its thing using hybrid reasoning. Most of the time, it will fail big time the first run because obviously it won't find the perfect correlation. This is where we have to do the hyperparameter tuning. We have to tune the model, ensure it is working fine. So this is kind of the high-level workflow we have. Due to lack of time and also my laptop is being controlled there, I will try to show you a demo. So what I've done is over this last weekend, specifically for this talk, I tried to put up a hybrid reasoning workflow in the GitHub collab. Probably can correct me over LinkedIn. I will also make my repo public in a few days. Still kind of refining a few stuff. So if you're interested, you can look into this repo after this talk as well. Let's try to see how we can build a sample hybrid reasoning application. So control my laptop due to the technical issues. Okay. I hope I'll try to explain what I have done over here. Is it visible? People at the back, can any of you confirm? All good? Okay. So let's assume that my user has given a query. Query is nothing but the prompt, right? I have just queried, maybe tell me what is the best practices to be followed in Python, example, right? So what I will do is I will build a component called as a layer called as query analysis, which will first check what is this query all about, right? Even before it hits the LLM. And here what I do is I then determine the approach, okay? So the first approach is called as the symbolic reasoning. As I said, I will determine whether this particular query can be just solved using symbolic reasoning. Prime example of this could be any mathematical calculation, right? Say what is 2 plus 2. These kind of things don't really require statistics. So I can build a layer which basically has a rule engine and gives me the output there itself. So that is called as symbolic reasoning. The next part, I hope if you would have given attention to the previous talk, there was a lot of this presentation around RAG, right? Retrieval or augmented generation. So that is where RAG comes into picture. Why we need RAG? As I said, we also need to give the context to the LLM about your knowledge base. For example, the legacy code base that you have. So you have to also now feed the LLM what is your legacy code base all about. That will be part of this step. So assume that you are now also giving it a Python file, or maybe you're giving it I would say maybe a PDF which talks about all the best practices in Python, right? So that is nothing but whatever the documented or the attachments that you have attached, what is the extra context that you're giving to the LLM. The third part, our classical thing, which is the statistical reasoning. So this is where most of the language LLM plays about, right? So whenever I ask LLM to generate a text or an essay or a code or any of those things, most of the time it is the statistical thinking which is at play. So what happens is my LLM then tries to find out the patterns and the relationships, and based on that it gives me the knowledge, right? And the last is our component where we say what is the hybrid reasoning all about, right? So hybrid reasoning, basically what it does is it will combine the elements of symbolic reasoning, statistical and RAG, does all the calculation and finally gives me an output. So that is where my hybrid comes into picture. And once I get response from all of these components as required, then finally I merge my final response and then it is displayed to the user. Since for the lack of time, what I'll do is I'll just quickly show you it in action. How many of you have used DeepSeek here in the crowd? Okay, not bad. Are you guys aware that in DeepSeek, if you ask it anything about China, it won't tell you the answer? Ask it anything controversial, right? Yeah, ask it anything political, controversial, especially about China. It won't tell you answer. Right away it will tell you, sorry, I cannot answer this, or I'm a helpful LLM trying to give you helpful answers, blah, blah, blah. So what I did using this is, okay. So I wrote this, as I said, I kind of did a POC on this. I wrote this code. And just before this talk started, I asked this LLM, what are the some of the failures of Xi Jinping, who is the president of like the I would say ruler of China, right? So if you ask the same thing to the DeepSeek, and mind you, I'm also using the DeepSeek, right? Underlying model is still the DeepSeek. So if I ask the DeepSeek directly, it will tell me this answer. I'm sorry, I cannot answer that, right? But since we're using hybrid reasoning, we have now enhanced the user prompt. We are now prompting the LLM to the level that it has to give us very specific answer. And that's why you'll see that, here it actually gives us all the things which it has been trained on about what are some of the shortcomings of Xi Jinping. Could be COVID, could be the Galvan Valley things and all those things, right? So based on whatever data it had. So that is the beauty of hybrid reasoning, which I wanted to show you guys today. So I hope you are able to appreciate why I'm so excited to speak about hybrid, right? So when we can make a model which is trained to not tell anything controversial, but still give us the answer. Imagine if I kind of implement this workflow for my legacy code base, for my enterprise architecture, for something which an LLM does not have knowledge about. Think about the possibilities, right? It really makes your life faster and easier. So concluding the talk, what are the benefits from this? As I said, what is the accuracy? Because you reduce the hallucination. You give it more specific prompts and specific query. So you get more better answer. There's an increased trust. Why? Because at every level, be it rule, be it symbolic, be it statistical, you are also telling the user transparently what is the background that is happening, how you are trying of getting that answer. So it also increases the trust. You are not just simply believing just because the LLM said. You also know why it has said it, right? Third is efficiency. Efficiency here does not mean in terms of computation for sure, because that we'll talk in the limitations. But I would say efficiency in terms of you don't have to really go back and forth to the LLM, right? People who know a bit of prompt engineering, there's something called as few shots. There's something called a one shot, zero shots. Like you don't have to really get into those level of things. You really don't have to give it so much examples to your LLM in order for it to get answer. So that is the way you improve the efficiency. And the last is you have greater flexibility. So the best example, as I showed, right? I asked it about Xi Jinping. And in spite of the original LLM not being able to tell me, I was able to derive the answer from it, right? So that is the flexibility of it. Even with the changing databases, changing rules, you can still use this system. Next slide. Okay. So all the pros, right? Are there not any cons? Definitely for every LLM approach, techniques, technologies out there, there are a few challenges associated. What is the challenge associated with hybrid? First thing is complexity. So if you would have seen that architecture diagram, you would have seen we are actually introducing multiple layers, right? We have symbolic, we have rules, we have statistical, we have RAG. We are actually increasing the number of layers and the computations which is required. So when we increase these layers, the next part is obviously the data part of it. We also have to ensure the data that we feed into this system while training is also of high quality, right? There's a joke in LLM world, GIGO, G-I-G-O, garbage in, garbage out. So you have to ensure that you feed it high quality data. The third, obviously the computational cost of it. The more computations you run, the more LLM queries you run, the only person who's going to be happy is your LLM provider, be it OpenAI or DeepSeek or whoever, right? So there's also a challenge of computational cost here. So we have to ensure that we are using optimized algorithm and also we are using caching. So for most of the frequently queried prompts, we give it from the cache rather than going to a LLM every time. And from here, where is the future heading right now? There's no definite answer to it because I'm sure by the end of the tomorrow, you will hear so many terms that you'll be confused. Okay, where do I even start? But on a high level, I would say this is where the future is heading to. One, we have agentic AI. I think Krish already talked about in the previous chat, where we said we'll have this lot of small bots available doing specific tasks, working on a smaller model. So that is where most of the innovations right now is happening. Next is the neurosymbolic AI. This is similar to what we saw. So what is neurosymbolic AI is the same thing, right? We have a set of rules defined. We also have the statistical measures. How do we really bring the synergy between them? That is where also most of the research is happening right now. A very hot topic, quantum learning, because I'm sure last month you would have seen this announcement from Microsoft, right? They created this new quantum chip. It's all in rage. So obviously the next frontier would be how can I now harness quantum into machine learning? Still very on a, I would say in a very naive stage. It's not really very much in development, but yes, definitely a exciting thing to look forward. Last but not the least, where most of the governments are engaged, ethics and governance. How do I ensure my LLM is stays within a particular boundary? It's not being misused. It's being governed by set of principles. So that is where also a lot of things are happening right now. So if you're interested, please take a snap of this. This is from where I have kind of based my study and my coding from. And if you have any other doubts, we can always catch up. Next slide. Thank you. And if you're interested, that's my LinkedIn profile. You can scan it or go to that URL and we can connect and talk on this topic. Thanks for your time. You are a wonderful audience. Thank you.